Okay, so welcome to everybody. So welcome to Mabi Statistics. So today we are going to discuss about the second section, descriptive statistics. So earlier we discussed in first video, we discussed introduction to statistics. So in this section, we have this descriptive statistics Q section. So first we are going to discuss that this is the part one video. So descriptive statistics. So in the chapter, this is actually our second chapter. So first descriptive statistics. So first we are going to discuss that how to organize the data and how to display the data. And this popular organizing method is frequency table. So we will discuss that frequency table and some graphical displays such as pie chart, bar chart, and stem and leaf diagram, box plot, and also then we will discuss the numerical measures. So numerical measures, in this case we have two important numerical measures: measures of central tendency and measure of variation, and also we will discuss the measures of position. So these measures of central tendency case, we will discuss mode calculation, mean calculation, median calculation, and also maybe we will discuss some several other calculation. And measures of variation, range and standard deviation calculation, variance calculation, uh, coefficient of variance, and also measures of position case. We'll discuss the quartile, percentile, and deciles. So first we are going to discuss that organizing and displaying the data. So when the data are collected in original form, they are called raw data. So that means initial collected data we call raw data. So to describe the situation, draw the conclusion and make inference about events, raw data must be organized in some meaningful way. The most common method in organizing raw data construct a frequency table. So this is very popular method for organize the data, raw data to some meaningful. Uh, Actually, in this case, there is frequency table, but just to change the tabular form. So, this here given this table 2.1 shows an example of raw data which gives 40 national football league players weight in pound. So this is the data. So we have 40 observation for the NFL players weight. So actually this according to this data, this is actually our initial collected data. So there is raw data. So very few information can be obtained from looking this above raw data. So we must be changed in a meaningful way. So the most common method of organizing raw data is to construct a frequency table. So frequency table is table including different classes or groups and their respective frequencies. So count within that class how many observation or how many place weight has some within class. So frequencies is known as frequency table. A frequency table can be constructed using the following steps. So we have some standard steps. So first step one, determine the number of classes. So first we have to estimate the number of classes or groups, which is depend on sample size n. So the rule of thumb is the number of classes should be equal natural logarithm of n, natural logarithm of sample size. Here C, this standard notation C is the number of classes, is ln is standard for the natural logarithm. Maybe you can use the calculators or logarithm table, and you can use the logarithm of n. So step 2, determine the range of the data. So you know that range means maximum value minus minimum value, or higher value minus lower value should be the range. So that is step 2. And step 3, determine the class width or length of the class interval. So it should be equal range divided by C. So that means range divided by number of classes. And step 4, determine the classes by introducing an extra decimal position so that each data values belongs to exactly one class. And also this decimal position adjustment also important. For we have to change, suppose if you want to plot the histogram, first we have to change that in continuous. So that means inside strictly we call continuity correction. So that is step 4. In step 5, use tally mark to put all data values in different classes and count the tallies or find the frequencies for each class. So it is not mandatory, but maybe if we use tally simple, then maybe we can easy to calculate that corresponding frequency values. So actually in this case our main purpose, first we have to split that groups, suitable groups, so then we have to count that how many frequencies, so how many offset count. So maybe we can use that tally simple, this easy way. Alright, so I'm going to discuss this example. So already we see that previous slides given some that exam table 2.1 given NFL 40 NFL players weight. So we can construct it, just follow that step by step. So step 1, first we have to estimate the number of classes. So it should be say is equal to logarithm of n. So in this case we have 40 observation, so logarithm of 40, so actually that value maybe should be equal to 3.87 or something. So that is approximately 4. This is number of classes, so number of classes should be integer, not an decimal point. So we have to write down in suitable integer value. Then step 1, step 2, range calculation. So maximum minus minimum. So this maximum value 331 and minimum value 152. So that should be equal 179. That is step 2. And step 3, class width or class width calculation. So it is equal range divided by number of classes. So in this case range is equal 179 and number of classes 4. So 179 divided by 4 is approximately 45. So this class width 45. Instead for the classes are first this is our lower minimum value 152 and this is actually maximum value. So this 152 plus 100 plus class width 45, that should be equal second interval lower value, and this one plus 45, that should be third interval lower value, and this one plus 45 last interval lower value. Then this is 196, that's why this is 152 to 197, but these are inclusive. So that means 197 is inclusive in this interval. So we have to write on here 196. And also in this case are all values integer values, not any decimal point. So we can try 152 to 196. So suppose if you count that number of integers 152 to 196, also these are inclusive, and you will get 45 observation. And step 5, this class boundaries. So we have to, this is just we could class limit. So in this case this 152 to 196, so these are not continuous, so we have to make it that continuity correction. So that continuity correction means just first we have to calculate this difference between two consecutive class lower and upper values and divided by 2, then that values plus upper value and that value minus with lower value. So that means class boundary, in this case the difference 1, so we'll just divide by 2 0.5, so 1.5 sorry 152 minus 0.5, that should be equal 151.5 and 196.5. so now you can see this is class boundaries, so now this is continuous, 151.5 to 196.5. Here the starting point 196.5 to 240.5. And also in this case, this is inclusive, this is exclusive. So that means each lower value is inclusive, upper value is exclusive. So next maybe we can use this tally simple. So just how many observations for this interval. So in this case, this 12 observation, 12 NFL players weight lies between 152 and 196, or 152 or 196. And similarly, 7 frequencies for this class interval, and 14 for this class interval, and 7 for this class interval. So maybe, but this tally simple approach is not important. But maybe if you use the tally simple, then maybe you can easy to count the frequencies. So, and also in this section we have some standard method, some terms of how many use describe frequency table are given below. First, lower class limit are the smallest number that can be belongs to different classes. So according to the table, 152, 197, 242 to 86 are lower class limit, and similarly these are upper class limit. So this is class limit, this 196 to 41 to 86. So these are upper class limit. And also class boundaries calculation. First you have to consider any two consecutive class lower limit and upper limit. Just calculate the difference between lower and upper two consecutive classes. So then just divide it by 2, subtract the half of the cap each of the lower limit and half of the cap each of the upper limit with add. So actually in this earlier example, class with, that means there's gap between these two consecutive class, 1, so 1 divided by 2, 0.5, so 0.5 add with our upper values and subtract from lower values. So then maybe we can get that class boundaries. Okay, so class midpoint. So class midpoint also some of the situation is also useful. So class midpoint means, suppose if you calculated first class midpoint, so yes, you have to add first upper class limit plus lower class limit divided by 2, or upper class boundary plus lower class boundary divided by 2. So that should be equal to midpoint. And class with the difference between two consecutive lower class limit or two consecutive lower class boundaries. So based on, suppose if they given some of the situation, they given frequency table. So suppose if you want to calculate the class width from frequency table, so you can use this way. So two consecutive lower class boundaries or two consecutive lower class limits. So that should be equal. That means the difference should be equal class width. And also additional guidance constructing frequency table in statistics. So usually there are between 5 to 12 20 classes. So there's avoid having too few or too many classes. The researcher decide how many classes to use. So that means actually that is depend on situation of our data analysis. And second, the classes are mutually exclusive, non-overlapping. So you have to assign one of the observation in one interval. So you cannot assign that observation for two different intervals. And the classes are continuous. So classes must be continuous. And that's why in this case our main focus we are going to draw the histogram. So that situation first we have to make the continuity correction. And the classes extractive accommodate all the data. So that means suppose if you calculate total number of frequencies would be equal total number of observation. That is important. The classes are equal in width. So and also you have to maintain all classes are equal width. So next, cumulative and relative frequency table. So this is also maybe some situation this is useful. So frequency of the class is the number of data values can change in specific class. So sometimes it is helpful to construct cumulative or relative frequency table. The cumulative frequency for class is the sum of the frequencies for that class and all previous classes The cumulative frequency table is basically the list of classes and their respective cumulative frequencies. And similarly, relative frequency are obtained dividing the class frequency by total number of frequencies observation, which is the sum of all frequencies. So it should be equal to total number of observation. So maybe later we will discuss the calculation. So the relative frequency is equal frequency divided by total frequency. And this is the example. So that cumulative frequency means first cumulative frequency should be equal first corresponding frequency. Second cumulative frequency is equal this previous cumulative frequency plus corresponding frequency. So that means 12 plus 7 should be equal 90. And similarly, third cumulative frequency is equal previous cumulative frequency plus corresponding frequency. 19 plus 14 should be equal 33, and finally should be equal 40. So actually in this case, in every situation, your last cumulative frequency should be equal total number of observation. And also this related frequency, so related frequency means corresponding frequency divided by total number of observation or total number of frequency. So this total number of observation here 40, so just for 12 divided by 40, 7 divided by 40, and 14 divided by 40, 7 divided by 40, that is relative frequency. With some of the situation this is useful. For example, suppose if they ask how many players weight less than 286.5, so that situation maybe you can say 33 players weight case less than 286.5. So that situation maybe it is useful with cumulative frequency. Alright, so next, graphical displays. So in this case there are several graphical displays. So just only in this case we will discuss some important graphical displays. So first, just we discuss that organize the data. So just popular method frequency table. So then maybe they can present in graphical form. The purpose is to describe the data using tabular or pictorial form. There are many graphical displays such as stem leaf diagram or stem leaf display, and bar diagram, pie diagram, histogram, and relative frequency histogram, and box plot. So in this case, yes, we will discuss one by one. So first histogram. So we use visual tool called histogram to analyze the shape of the distribution of the data. It is graph consisting of bars of equal width drawn adjacent to each other. So in this case, this is very important without gaps. So you have to maintain no gaps between that bars. The horizontal scale represents the classes quantitative data, and vertical scale represents the frequencies. So in x-axis we have to represent that classes, and y-axis is number of frequencies. So the height of the bars corresponds to frequency values, and also this without gaps. So that is very important. So this is that histogram for our example data. So here no gap between that variable, and this is the frequency, first frequency 12 and second frequency 7, third one 14, and last one also 7. So and also in this case maybe in y-axis as frequency, and x-axis as we have some standard method. Maybe we can label class boundaries or class midpoint or lower class limit. So in this case, maybe suppose if you indicate the lower class limit, you have to introduce the small error. So that means our natural starting point 0. So maybe suppose then if you start your first bar maybe is 142.5, so yes, you have to use the same part. Maybe suppose this is our first bar, so then you have to use this continuity correction. Okay, so the horizontal scale histogram is class boundaries or class midpoint or lower class limit, and vertical axis class boundaries. And next, relative frequency histogram. This early histogram case, y-axis classes or class boundaries or low class boundary, and y-axis as frequency. But in this case, relative frequency histogram. So here y-axis as relative frequency. That is just only different. But maybe shape of the distribution, it is exactly the same for histogram, usual histogram. So maybe some situation this is useful. And these are just common shape of the distribution. So suppose a histogram this pattern, we call that is uniform and symmetrical. Suppose this case skewed right, this is skewed left, this is symmetric. So actually maybe later we will discuss this symmetric means this is bell shape here. And this is bimodal or symmetric, so maybe later we will discuss that modal calculation, mode value calculation. So in this case we have two mode values maybe, and this is bimodal skewed right, so bimodal and skewed right. So these are just common shape the distribution maybe. After the draw the histogram, so we can use the histogram, so we can identify the shape of the histogram. Alright, so next stem and leaf display. So stem and leaf display is the simplest method of summarizing numerical data set when the number of observations data is not too large. So this is very easy way. So from quick governance of the data, grouping is established the common leading digit or known as stem and remaining digit as leaves. So this common leading digit as known as stem and remaining digit are known as leaves. The stem and leaf displays formed for the NFL data. So that means our previous example data. So in this case, this I think minimum value 152, maximum value 331. So this common leading unit as 1, 2, 3. So that means first we have to arrange the data in order. So that is better way, but it is not necessary. But if you arrange this data in increasing order, you can easy to write down that corresponding stem and leaf. And also maybe the shape is also maybe pretty nice. So arrange the data order is not essential and can be cumbersome when the data set is large. However, it is helpful in constructing a stem and leaf plot. The leaves in final stem and leaf plot should be arranged in order. Step 2. Separate the data according to first digit as zone. So in this case, maybe first digit as 100 is 1. And step 3. Display can be made using leading digit as stem and trailing digit as leaf. So this is that means 156, 178, 192, 187, 152 up to last one 331. 331. First one 156. So this is easy way. So stem displays shows a quick distributional pattern of the data as it can be seen in above example. The measurement within the leaves are not necessarily ordered, but if you arrange in increasing order, then maybe this pattern is maybe it is pretty nice. Stems can be repeated for lower and higher values whenever necessary. So this is also another way. This is we call double stem and leaf display. So in this case we have there are three groups, so just we split that groups in each two groups. So have more groups, each groups could be divided low and high. So that means in this case just we consider 100 to 150 is one low, 150 to 200, 199 one high. So maybe there's also maybe some situation this is useful. So this we call double stem and leaf plot. And also maybe if you want to divide it three, then maybe we can divide it one low, one mid, one high, two low, two mid, two high, whatever. Alright, so next bar graph. So this is everybody familiar this bar chart. So use bars of equal widths of frequencies. So actually this is maybe useful for qualitative data. So the vertical scores represent count or amount of respective category and height of the bar. And horizontal scale identify different categories or labels of qualitative data. And also we have several bar graph is possible. So multiple bar graph has two or more set of bars and is used to compare two or more set of data. So this was just a simple example. So this is actually multiple bar graph, so different years, and here income, and these are, here we have this blue color represent total revenues, and maroon color represent total expenses, and green color profit or loss. So, and this is another way, multiple bar graph. So in this case also maybe y-axis as categories and x-axis as count and girl and boys. So there's another way. We have several ways that bar graph, and also we have some percentage bar graph, and different maybe we have a lot of several types of bar graph. So okay, now so next pie chart. Pie chart is like a divide up into sector which are representative of the data. In pie chart, each category is shown as a fraction of circle. So for example, in survey, half of the people asked dropped to work, a quarter work, and quarter went to bypass. So that means half mean 180, total 360 degree. So this 180 degree, and quarter mean this is 90 degree. This is also 90 degree, and this is simple pie chart, pie diagram. So suppose if you want to draw the pie diagram, so now I am going to explain simple example. For example, 30 people were asked the newspaper. So we have different newspapers and corresponding number of people. So suppose if you want to draw the pie diagram, first we have to have the total number of papers and also calculate that corresponding angle, how many degrees. So total 360 degree. So just calculate each corresponding people how much represented corresponding degrees. So this guardian 8 people, so this total values, if you calculate the total values, uh, this total is equal 30. So total degree 360 degree, so 360 divided by 30 is equal 12 degree. So 1 people represent 12 degree, so 8 people represent 8 into 12 degree, and similarly second one, so that should be equal 96, so this corresponding angle 96. Similarly 7 into 12 degree, and it should be 84 degree, and 3 into 12 36 degree, 72 degree, and last one also 72 degree. So then we can draw that pie diagram. So we have to start from this point, so and also this clockwise direction. So first 96, the guardian 96, and the daily mirror 84, and the third one 36 the times, and 72, last one also 72. So this is the pie diagram, the easy way. And also next, skewness. So just in this section, just we will introduce that skewness, but maybe later we will discuss that skewness calculation based on some mathematical way. So in this case, just we identify that skewness based on the histogram or the graphical way. A distribution is skewed if one of tail is longer than other. So the third distribution, so this distribution we look as positive skew. So this means it gets longer tail in positive direction, so this direction. So and similarly this longer tail has negative direction, so this is we call negative skew. This is positive skewed, this is positive skewed, this is negative skewed. And also suppose this way, so in this case this is symmetric pattern, so maybe we call bell-shaped curve. So this is yes normal or no skewness. So in this case positive skewness, negative skewness, or also we call this is positive, we call this is right skewed, so that means right side skewed. This is left side skewed, so we call negative skewed or mm, left skewed. Okay, so next, numerical measures. So numerical measures. So in this case, mainly we have three numerical measures. So first, measures of standard tendency, and measure of variation or dispersion, and finally we will discuss measures of dispersion. So first, measures of standard tendency. So in this case, we have three important measures of standard tendency: mean, mode, median. So first we are going to discuss the mean calculation. So usually we called arithmetic mean. The measures of standard obtained by adding the values and dividing the total by number of values. So actually arithmetic mean is equal sum of all observation divided by total number of observation. And or maybe usually people use the word average. So and also I would like to introduce the notation. So this is this we call sigma, so that means summation notation, sum of set of all values. And also we usually simple x as variable, and symbol m is already this number of data values or number of observation in sample, and big number of data values or number of observation in population. So this is also pronounced x bar, is denoted as mean of the data sample. So that means sum of all observation divided by n. So that means x1 plus x2 up to xn divided by n. And there is sample mean, and population mean we use the notation mu. So that belongs to mu denotes the number of values in the population. So that should be equal total number of observation in the population. So in this case we have big N number of observations. So that means x1 plus x2 up to xn divided by total number of observation in population. So that is population mean, but usually this is unknown. That's why this is maybe usually is too large, but we can estimate this population mean from sample. So this is just simple example. The sample mean is an unbiased estimator of the population mean, and it is true for any arbitrary population. So maybe later we will prove this result based on some simple example. That in this case they given some 10 students statistic class marks. So suppose if you want to calculate mean score, then sum of these all students marks divided by 10, so that should be equals 80.9. So class average of the student average 80.9. Alright, so next example 2.6. So let us consider population for 4 values. So in this case, just we consider this as population, and also we are going to select sample size 2 with replacement. So that means just we are going to pick two numbers from these 4 groups. So this is population. So if you calculate the population mean, mu is equal to 2.5. If you select the sample, maybe possible in this case with replacement, so 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4 up to 4 comma 4. So we can select maybe 16 possible samples. So in this case, don't forget this is population mean. So in this case we can calculate the population. So because I am going to verify the result, so mu is equal to 2.5. Then calculate this each x values, average values. So first corresponding average value 1. 1 plus 1 divided by 2, so that should be equal to 1. And 1 plus 2 divided by 2, that should be equal to 1.5. Similarly, the last one, 4 plus 4 divided by 2 should be equal to 4. So these are the corresponding sample. Suppose if you calculate this average of this average, so that means sum of these all observation divided by 16, that should be equal to 2.5. So already we have population mean also 2.5. So in this case the average of average also equal to 2.5. So that's also useful result. and also mean of group frequency data. So maybe suppose they given any frequency table, so that's the division how to calculate that average. So that's the division. Our formula should be equal x bar is equal to summation of f into xm divided by n. So in this case n is equal summation of f, this is corresponding frequency, this is corresponding midpoint, class midpoint. So this is the procedure table, so you have to follow this procedure. First step, in this case they given class and frequency, so you have to find out the midpoint and calculate that product of midpoint and corresponding frequency. That means in this case you have to construct that new two columns. Then find the sum of column D should be equal our numerator term, this one, and summation of F, this column B, sum of this column should be equal n. So then just divided by this one divided by this, so equal to x bar is equal to this one. So this is the procedure table. So here also I also given one example. So in this case this is that class and frequency, so we can calculate that midpoint values. So just apply that lower limit plus upper limit divided by 2. Yes, so we have to generate the new column f into xm, and actually in this case they given the two columns, so we have to create the third column as midpoint and fourth column as product of frequency and midpoint. So this is the midpoint values, and midpoint mean 10 plus 6 divided by 2, that should be 8. 11 plus 15 divided by 2, 13. And similarly last one, 36 plus 40 divided by 2 should be equal to 38. And then that product of 1 into 8, 2 into 13, 26. So you have to create the fourth column. So this summation of this one should be equal our numerator term, and accumulated total frequency should be equal to 20. So our x bar 490 divided by 20, that should be equal to 24.5. Alright, so this is the example, maybe you can try it yourself. So it is also similar, same type of example, they given the frequency, so you have to generate a new column, so that is midpoint, and last one maybe product of f into xm. So then this summation should be equal total number of summation of f into xm divided by frequency total sum of this one, that should be equal to mean. So you can try it yourself, that is practice for you. Alright, so next median. So median can be for the population, for example. So due to similarity in calculation, we will discuss only for samples. So median we denote as usually big M is the midpoint of the distribution. So that means half of the observation are smaller than median and other half larger than median. So that means this is midpoint of the distribution. So it is not affected by an extreme value because this is actually just position. So this is not affected for extreme value. It's resistant measures of center. So finding the median, you have to follow the steps. So first step, we have to arrange the observation in order, in increasing order, so smallest to largest. And second, you have to identify the location. So that means n plus 1 by 2 item. So this is the location point, this is the position. So 8 means number of observation. So then located n plus 1 by 2 position measurement in the orders list, which is the median. And in step 3, if the number of observation in n is odd, so maybe n should be odd number, n plus 1 by 2 should be even. So maybe we can identify that exact point. So suppose this is even number, this value is not integer. So that situation we have to calculate this average of two numbers. So for example, yeah, and also here important, this is median, this is just not median, this is just median position n plus 1 by 2, and number of values is odd, then median is middle number, and number of values is even, the median is average of the two middle numbers. And not that n plus 1 by 2, and not the value of the median. This is important. The position of the median is rank data, that means increasing code, increasing data. This is simple example, random sample of NBA players height. So they're given here 7 players height. So first we have to write down in increasing order. So 6.23 as minimum value, maximum 7.12. So then find out that location. So n plus 1 by 2. So in this case n is equal to 7. So 7 plus 1 by 2. So that should be equal to fourth item. So this is first item, second item, third item, fourth item. So 6.68 as median. Okay. So here important is step 1 is very important. So this, in this case, this sample size 7. Suppose sample size even number situation. So in this case, sample size 8. So first step, we have to write down in increasing order. So then identify that location. So in this case, that location 8 plus 1 by 2 should be equal to 4.5. So this is first item, second item, third item, fourth item. So 4.5 means lies between fourth item and fifth item. So that means you have to calculate this average of these two numbers. So that means in this case 6.68 plus 6.78 divided by 2, that should be equal 6.73. So median is equal 6.73. Alright, so next mode value. So mode is another measure of center. So this mode means most frequent value or values. Maybe some situation we have more than two modes or two more mode values or one mode values or more than two modes, 3 or 4 modes. So and also this most typical value in the data set can have one or more than one, or some situation no mod. So mod is only measurement for nominal type data. So this in this case just we have specially we call, suppose if our data set contain two mod values, that means two data values with the same greatest frequency, so that situation we call this binary. Or maybe more than two values of the same greatest frequency, that time we call multimodal. Some situation not data values, that situation that's not mod. So this is just simple example. So in this case, this is first one, this mod is 9, and in this case, second case, there is no mod values. So mod 9 in second. Right, so this is just first part 1's descriptive statistics part 1's slide ending time. So please don't forget to subscribe my channel. So and also next video we'll discuss this part 2. So part 2 we will discuss some mod calculation, and also maybe we will discuss some measures of distribution and measures of position. So and also maybe I'll show that mathematical calculation and some calculator calculation too. Thanks for watching. So see you on next video. So please don't forget to subscribe my channel. Thank you for everyone.